Learn all about the Document Object Model, or DOM, which is the fundamental interface that connects your code to a web page. This in-depth course is great for beginner web developers who are ready to build dynamic user interfaces. The course starts by defining what the DOM is and how to analyze its structure. You'll then gain important skills in navigation by learning how to expertly traverse the DOM elements and hierarchy. The core focus will be manipulating the DOM, updating content, structure, and styling, and listening to DOM events for interactive experiences. Finally, the course combines all concepts by guiding you through a complete project, building a functional expense tracker application from scratch, giving you a strong, necessary foundation for modern web development.
Welcome everyone. I hope you all are doing well. In this video series, we are going to learn about one of the most important topics in JavaScript, the DOM. Throughout the series, we will explore what the DOM really is, how it works, and the different features it provides us. Along the way, we'll also build a beginner-friendly project together, an expense tracker. This project will give you hands-on experience and help you strengthen your understanding of both JavaScript and the DOM. At the end of the video, I will also share some simple project ideas that you can practice on your own, which will make your learning even stronger. If you ever get stuck or feel confused while practicing, just leave a comment or make a public post on social media and mention the Logic Based Labs page. We will do our best to understand your issue and guide you towards the solution. I am confident this will be an exciting journey for you, but before we dive in, remember that you should already have a good grasp of JavaScript along with some basic knowledge of HTML and CSS. If you feel confident about these basics, then without any further delay, let's begin our journey into learning the DOM. So, the very first question is, what is the DOM? The DOM is one of the most important concepts in JavaScript. JavaScript is what makes a web page interactive. But how does it do that? Through the DOM. By manipulating the DOM, we can control the content, the structure, and even the styling of a page. To really understand the DOM, we need to break it down into its three parts, D, O, and M. First, think about this. When we look at a web page, its main structure comes from HTML, right? For example, what you are seeing right now is loaded from a file called index.html. The HTML code we wrote is exactly what's inside that file. In the same way, in our file system, an image like a JPG or PNG or a Microsoft Word or PowerPoint file, these all exist as separate files. We often call them documents too, like a Microsoft Word document file or an image document file. The index.html file on our computer is also just another document in our file system. And this idea of a document in HTML is where the D in document comes from. That's why we call the HTML page itself a document. And the D in DOM represents exactly that. Now comes the O, which stands for object. Let's take the index.html file I showed earlier. Inside that file, we write HTML code like this. That HTML code is made up of different HTML elements. So what do we call elements? For example, head, body, div, h1, all of these are HTML elements. But remember, they are not just plain text. Even though we write them as text, in reality, each of them exists as an object. In other words, every element is represented as an object. Because whenever JavaScript manipulates something or works with it, at the end of the day, it sees everything as an object. JavaScript doesn't recognize anything outside of objects. For example, if I have used a div in the code and I want JavaScript to understand that div and later perform some operations on it, JavaScript has to treat that div not as text, but as an object. And that's how we get full control over things. And that's why even though we see the code written as plain text, behind the scene, JavaScript converts them into HTML elements. All these HTML elements are actually objects. And that's why the O in DOM comes from object. So now we have reached DO. Let's move on to M. The HTML code we just looked at can easily be imagined as a T structure. You see, in the browser, everything exists as an object, and those objects take the form of a tree. There's a parent node at the top. Beneath it are various properties, and those properties can also have their own sub-properties. So you always have to start from somewhere, and that starting point is the window object, the global context. In the case of a browser, this is what we call the window context or the global object. So after the window object comes the document and then our HTML, which we write using HTML tags. After that comes the head and then the body, right? Inside the head, we have the title along with many other types of meta information. So based on the example we just saw, we can imagine the tree structure like this. This HTML tree structure that we are visualizing is what we call the tree model, the model of the HTML tree structure. And it's from this word model that the M in DOM comes. Got it? So these three together form the whole idea. Document, that's our index.html or any HTML file, and that's where the D in DOM comes from. Each HTML element is treated as an object so that scripts can work with them and perform operations as needed. That's why every element is converted into a JavaScript object, and that's where the O comes from. Finally, the entire HTML element is represented as a T structure, which we call a model, and that's where the M comes from. Put it all together and you get the document object model or DOM. At first, the name might sound complicated, but in reality, it's actually very simple, isn't it? I hope you have got the idea so far. When we build a REST API, there are usually 4 main operations: create, read, update, and delete. Together, these are called CRUD. These CRUD operations are very common. Almost every web application is basically built around these 4 actions. To put it simply, create means adding something new. Read means retrieving the data of an element or object. Update means modifying existing data, and delete means removing it. The names explain themselves, don't they? What happens is JavaScript reads the HTML we have written and creates a tree model inside the browser. That's called the DOM tree. Each element exists as an object, and we can perform CRUD operations on these objects. Makes sense, right? We know that the C in CRUD stands for create. Inside the DOM, we can create a new element. For example, we could make a p tag element and put the text hello inside it. That's what we call a create operation. And we can also perform read, the R in CRUD. For example, we can read the text inside an h1 element if we want. Then comes U, which stands for update. Let's say the value of a p element was document object model. We can update it to just DOM. We can even change the type of an element. For instance, update a p element and turn it into a span. You get the idea, right? We can also delete an element entirely if we want. For example, the h1 tag I just removed, that shows we have full control, right? If we had to write the entire HTML only with JavaScript objects, then we would need to manually create every single part of the HTML code ourselves. Instead of that hassle, HTML works as a shortcut markup language. By writing it, we tell the browser what structure we want. In the end, the browser converts each element into the DOM, turning everything into JavaScript objects so developers can grab these elements later and perform operations on them. In short, that's the essence of the DOM. It's the model on which we carry out different operations. From here on, we will go step by step and see how these operations are done. In other words, DOM manipulation or working with the DOM. In the last lesson, we went through the theoretical explanation of the DOM. Now let's switch over to the practical side and see how the DOM actually looks and works in the language of JavaScript. To do that, here's the setup I have prepared. I have my Visual Studio Code editor open in one window, and in another window, I have opened Google Chrome. The idea is simple. I will write code in the editor and then immediately switch over to the browser window to check the output. Right now, I have a very simple index.html file. Inside that, I have included a style.css file just to make things look a little nicer. I have added some basic styles there. And finally, at the end, I have linked a script.js file, which for now is completely empty. My plan is to write different pieces of code inside the script.js file and instantly check the output in the browser. To make that possible, I have installed a VS Code plugin called Live Server. Many of you probably already have it, but if you don't, you can easily install it. This plugin was created by Ritik De, and I will also share the link in the description. The main benefit of Live Server is that whenever we make any change to our index.html file or script.js file and hit save, those changes will instantly reflect in the browser. That way, we will be able to see the live updates right away. To use this plugin, we simply right-click inside the index.html file and select Open with Live Server. As you can see, the output instantly appears on the right side of the browser. From now on, whenever I make a change in the code and save the file, the output will update accordingly. For example, inside the H1 tag, if I change the text from expense tracker to expense tracker app and then save the file, you will notice the change happens right away in the browser. Now it's time to start writing our code inside script.js. To make things easier to follow, let's keep the browser console open, since that's where our outputs will appear. With this setup, we will finally get to see what the DOM actually looks like. So earlier I mentioned the document object model. Well, the document object itself basically the DOM. Now, if we want to actually see that document object, we can write this in our script.js file, console.dir in the bracket document. Then after saving the file, we can check the browser console. There we will find that it shows up as an object. To confirm that further, I also tried logging it with console.log and then checked its type using typeof. So I wrote typeof document. After saving, the console clearly tells us it's an object, and that's exactly why it's called the document object model. Now let's go back to where we were. I switched console.log back to console.dir and removed the typeof part. If we take a closer look at this document object in the console, you will notice it contains a huge number of properties and methods. For example, properties like URL, active element, etc. are clearly visible. Alongside this, there are tons of methods as well. Of course, it's impossible to cover everything here since there are literally thousands of properties and methods inside the DOM. So what we will do is focus on the most useful ones and explore them step by step. For example, the title of this page that you are seeing in the browser tab, where do you actually write that in the code? We set it inside the head section of index.html, especially within the title tag. Now, if we want to check the title in the console, we can simply write console.log in the bracket document.title. And notice, it shows up right away. If you use console.dir and in the bracket document, then look inside the object in the console. You will also find a property named title. This works exactly like how we normally access properties from any JavaScript object. We just use object.notation to access them. Similarly, suppose you want to see the URL of your web page. In that case, just like before, you can write console.log in the bracket document.url. That way, you are accessing the URL property of the document object. After saving and checking the console, we can see the URL has appeared. Now, suppose we want to display just the domain name. Then we simply write document.domain and we will get the domain. In the same way, if we want to access the entire head section from index.html, you can do that with document.head and instantly the full head section will show up. At this point, a common question might come to your mind. Earlier, I said everything inside the DOM is an object, but here it looks like it's showing raw HTML, almost like a string. Why is that? To understand this clearly, let's check its type. Just write typeof document.head and look at the console output. It says object. So even though it looks like HTML when displayed, behind the scenes, it's actually an object. Since HTML elements are something the browser is already very familiar with, whenever the browser encounters them, it displayed them nicely in an HTML-like format. But in reality, each of those is an object. That's why inside the DOM, all the different elements are actually JavaScript objects. The reason behind this is simple. JavaScript can't really work with anything unless it's converted into an object. For JavaScript, almost everything is treated as an object because only then can we perform different operations on it. That's exactly why the DOM is structured this way. If we now use console.dir in the bracket document.head, you will see that it's actually an object filled with tons of properties and methods. In the same way, every single HTML element is, in fact, an object. So, if I write console.log in the bracket document.body, the browser console will print the entire body section. That's why we call it the document object model, because every element is represented as an object. And not just for reading, we can also manipulate them dynamically. Remember how we accessed document.title earlier? If we change its value directly, it will instantly update the actual title of the document. Interesting, right? For example, if I write document.title is equal to play with DOM, you will notice that the page title itself changes right away. Notice how the document title in the browser has changed actually. This shows that you have full control over what gets rendered in the browser. With the DOM, we can do all kinds of amazing things, which is why understanding it is so important. Now, let me show you something else. If we write console.log in the bracket document.all, you will see some output appear in the console. At first glance, it might look like an array. But if I check its type by writing type of document.all and then save, you will notice something interesting. The type doesn't show up as expected. Instead, it displays undefined, right? Now let's go back again and remove the type of part. Looking at the console, document.all really does look like an array. You can even see a bunch of elements inside it. But the truth is, it's not actually an array. Let's prove it. We know that with arrays, we can run loops using methods like forEach, right? So if we try calling document.all.forEach, the console immediately throws an error saying document.all.forEach is not a function. This clearly proves that document.all is not an array. It only looks like one, but in reality, it's an object. More specifically, it's a special type of object known as an HTML all collection. Exactly, this is a collection, and if you look closely at what's inside this collection, you will notice it starts with HTML, then head, then meta, just like the order in your index.html file. Compare it carefully. At the very top of index.html, you have the HTML tag, and in the console, the first item is also HTML. After that comes head, then inside head, you see the 3 meta tags, followed by title, the link, and the body. So the browser organizes everything in sequence, one element after another, exactly as they appear from top to bottom in the HTML file. Now, in this particular page, the collection contains around 161 elements. If your HTML file grows bigger, this object will also grow accordingly. Here's something interesting. Even though document.all is not an array, you can still loop through it. That means you can iterate over each element one by one and traverse the entire collection. So, how do we do that? Well, if we expand the prototype property of any element from the console, we will see that it contains symbol.iterator. And the presence of symbol.iterator means we can iterate over it. That's why whether we use a regular for loop or a for off loop, we are able to loop through this collection. If you want to try it out, just write for let element of document.all and inside that loop, put console.log. So each element gets printed one by one. After saving, check the console. You'll see that all the elements are showing up individually. This proves that we can loop through document.all, and the reason is that it has symbol.iterator built into it. That means to iterate over an HTML all collection type list, we can use either a for loop or a for off loop. And not just that, besides looping, we can also access elements inside an HTML all collection just like we do with arrays. For example, if we skip the loop code and directly write console.log in the bracket document.all square bracket 4, notice in the console it shows the title element because the index for the title is 4. See, the title has appeared in the browser console, but this isn't really the standard way we select DOM elements. You might be thinking, well, if I can access elements with square brackets and array indexes, then why not just use that all the time to manipulate the DOM? The truth is, it doesn't work that way. This method isn't reliable or practical for selecting and working with elements in the DOM. The reason behind is that when we work with JavaScript on a web page, many elements can change dynamically. Different scripts can modify or add elements in various ways. And when that happens, the array-like indexes also shift. For example, right now, the title element is at index 4. But if I go back to index.html and add another meta tag just above the title, say a meta description with the content "We love JavaScript," then the title's index will no longer be 4. It will shift down. And right away, you will notice in the console that the title's index has shifted to 5. That's why you should never rely on indexes to manipulate the DOM. It's a very bad practice because your HTML document is dynamic. Over time, you will use third-party plugins, scripts, or even make changes yourself. And those can all rearrange elements, causing their indexes to change. That's why we never access DOM elements this way. It's simply not how things are done. So, how do you actually do it? That's something I will show you in the next lesson when we dive into DOM traversal. There, I will explain the proper way to select and navigate elements. But before we wrap up, let me show you one more thing. Suppose you want to grab all the images for your page, the entire set of images that exist on the document. How can we do that? So, if you write document.images, you will get back another HTML collection. Just like before, this isn't an array. Inside it, you will find all the images from your page. Since I only have one image in this page, it's showing just that single image inside the list. In the same way, if you want to fetch all the links, you can use document.links. But because my index.html doesn't have any links, it's returning nothing. Similarly, if you try document.forms, it will return all the forms present on the page. In my case, there's only one form, so it gave me just that one. So this is how you can print the document object and explore its different properties. You can experiment and play around with them as much as you want. That's it for the practical side of the document object model or DOM. In the next lesson, we will move forward. In the previous lesson, we saw how to access different properties inside the DOM. At that time, I mentioned that using document.all or selecting elements by index is never the right way. Now, we will explore how to properly select elements and what methods the browser provides for this. Let's start with getElementById. From the name itself, it's clear that if we assign an ID to an element, we can capture it using this method. For example, suppose there's an input element with the ID amount. If we write document.getElementById in the bracket amount, we will immediately get a reference to that input element. That means with the reference of that input element, we can fetch its value, update it with a new one, change its style, and perform many other operations. If we open our index.html file, we will notice plenty of IDs and classes. Why do we use these IDs and classes? Normally, we use them in CSS to style specific elements. But those same ID and class attributes can also be used inside JavaScript to create references. And with those references, we can perform different operations on those elements. But here's something very important to remember. On a web page, we can use the same class or multiple elements, but an ID must be unique. In other words, if we assign an ID to one element, we cannot reuse that same ID for another element. This is a rule you should always keep in mind. Alright, now let's see how we can capture an element using getElementById. In our index.html file, you will notice an input field with the ID amount. This is basically the ID for our amount input field. Let's now select it using JavaScript. For this, we write const input_field and then assign it like this. Document.getElementById in the bracket amount. Now, if we print the input_field variable in the console, you will see that the amount element shows up directly in the console. But notice carefully, this isn't plain text. It's an actual HTML element. If it were plain text, it wouldn't appear with those colorful highlights. What you are seeing is the actual HTML element itself. In the same way, we can use getElementById to create a reference for any HTML element and then work with it. Let's look at another example. In our index.html file, you will see an h1 element with the text expense tracker and a class name title. Since it doesn't yet have an ID attribute, let's assign one. So we give the h1 element an ID like this. ID is equal to expense_tracker. Got it? That means now we can use this expense_tracker ID to create a reference to that element. If we go back to our script.js file and replace the ID amount inside document.getElementById with expense_tracker, save the file and then check the browser console. You'll notice that our h1 element shows up there. Alright, now let's take it a step further. Instead of using console.log, we will define a variable like this. Const header element is equal to document.getElementById in the bracket expense_tracker. I hope this part is crystal clear. Next, we want to use the header element reference to change the text of our h1 element. Currently, it says expense tracker. To modify that, we will use header element.textContent. This is a property of the header element, and through it, we can change the text inside the element. So we write header element.textContent is equal to expense tracker application. With this small change, we have simply added the word application to the existing text. Now save the file and check your browser. You will see that the h1 element has been updated. Amazing, right? Pretty fun stuff. Alright, let's explore something new. Just like text content, there's another very similar property called inner text. Both of them practically do the same thing. If we test it out by replacing our existing header element.text content with header element.inner text, then save the file and reload the browser, you will see the exact same output. But there's a difference between the two. Let's try something. We will print both of them in the console side by side. First write console.log in the bracket header element.text content, and then write console.log header element.inner text. Now save the file and check the browser console. Notice carefully. You will see a slight difference in the outputs. The inner text result shows everything in the uppercase or capital letters, while text content shows the text exactly as it's written inside the index.html file. So what's the distinction? Inner text prints the text the way it's rendered in the browser, whereas text content prints the text exactly the way it's written in the HTML file. Hopefully that clears things up. Alright, here's another little thing. The properties text content and inner text only give us the actual text, not the HTML itself. But what if you want to access the HTML? That's very simple. Just write console.log in the bracket header element.inner HTML. And there you go. Now the console shows you the full HTML content. Easy to remember. Now let's move on to another interesting topic, styling. Remember what I mentioned earlier? The reference we got for header element, what type is it? It's an object. And as we know, objects come with different properties and methods. We have already seen some properties like text content, inner HTML, inner text. Just like the properties we have already explored, there's also a property for styling elements. It's called the style property. If we want to apply CSS styles directly to an element, we can do it using this style property. For example, suppose we want to style our header element. Let's say we want the header text color to turn red. We can do that like this. Header element.style.color is equal to red. After saving, if you check the browser, you will see the header text has turned red. Pretty cool, right? Here, style is a property of header element, and header element.style itself is an object. Inside this object, you will find properties like color, font size, padding, margin, border, and many more. Basically, anything you normally write in CSS is available as properties within this style object. But there's one thing you need to keep in mind. We are writing JavaScript, right? And the syntax of JavaScript is different from CSS. That means when applying styles, some CSS property names have to be written differently in JavaScript. For example, in CSS, we write font-size with a hyphen. But in JavaScript, we can't use a hyphen. Instead, we write it in camel case. So, font-size becomes font, S capital letter, then IZE. The rule is simple. Whenever there's a hyphen, remove it and capitalize the next letter. So, font size becomes font, S capital letter, and IZE. Background hyphen color becomes background, C capital letter, OLOR. Padding hyphen bottom becomes padding, B in capital letter, and the remaining, and so on. Let's implement this. First, we write header element.style.font-size is equal to 30 pixel to set the font size to 30 pixel. Next, we give it a background color. Header element.style.background color is equal to chocolate. That applies a chocolate colored background. Now save the file and check the browser. You will see that the font size has increased and the background has turned chocolate. But notice, if you mistakenly write header element.style.background hyphen color instead of background color, then after saving, the background color won't work. In fact, the console will even throw an error. And here's another thing. If you select the header element using Chrome DevTools element selector and look at the code, you will notice that the font size and background color styles you applied are injected directly as inline styles in the HTML. Remember this. Whenever we style using the style property in JavaScript, those styles are always added as inline styles inside the HTML. I hope you got the idea by now. For practice, you can try applying different CSS styles on your own. So far, we have seen how to manipulate the DOM using an elements ID. Now let's see how we can do the same with classes. In JavaScript, there's another method similar to document.getElementById, and that is document.getElements by class name. Notice the difference here. Earlier, it was getElement, singular, meaning just one element. But in the case of classes, it's getElements, plural. As I mentioned earlier, a web page can have multiple elements with the same class, but an ID must always be unique. That's why when we use getElementsByClassName to select elements by class, we don't just get one element. We get a collection, kind of like an array. This is exactly why the method name uses the plural form, getElements. Let's see this in practice. If you look at our index.html file, you will notice there are plenty of classes that have been used multiple times. For example, the class label is used several times. Then we also have classes like form group, transaction item, and so on. Suppose we want to target all the elements with the class name label. In our script.js file, we can write inside console.log document.getElementsByClassName in the bracket label. Now save the file and check the console. Notice what we get. It's an array-like list of all the elements with the class label. And what's the type of this array? It's an HTML collection. That means each item inside the HTML collection is one of the elements that has the label class. We can also select a specific element from this HTML collection using its index. For example, document.getElementsByClassName in the bracket label and then square brackets 0. Here we are grabbing the element at index 0, and if you check the console, you will see the very first element with the label class printed. In the same way, we can target other classes as well. For instance, in our index.html, we saw a class named transaction item. If we replace label with that and write console.log document.getElementsByClassName in the bracket transaction-item, then in the console, you will see all the elements with the transaction-item class grouped inside an HTML collection. In the last lesson, we saw how to loop over an HTML collection, right? So today, let's loop through all the transaction item elements and apply some simple styling to each of them. First, let's remove the console.log and instead we will write a for loop. But before that, we will store the transaction-item collection inside a variable. For that, we write const items is equal to document.getElementsByClassName in the bracket transaction-item. So now all of our elements are stored inside items. Next, we will run a for loop. For that, we write for let I is equal to 0, I less than items.length, I plus plus. This means the loop will keep running as long as I is less than items.length. And since items is a collection, items.length tells us how many elements are inside it. Pretty basic JavaScript, right? Inside the loop, we write items I dot style dot background color is equal to red. Here items I refers to the element at the ith index of the collection. On each iteration, the value of I increased by 1 and we apply styling to one element at a time, setting its background color to red. Simple. Now save the file and check the browser. You will see that all the items in the transaction history section have turned red. But of course, you can customize it however you like. For example, let's say we want odd indexed items to have a red background and even indexed items to have a green background. That's easy to do with a ternary operator. Inside the loop, we can write if I modulus 2 equals 0, then set the color to green. Otherwise, set it to red. In other words, on each iteration, the value of I will be divided by 2, and if the remainder is 0, we apply green, else we apply red. And don't worry, if you are not comfortable with the ternary operator, you can always use a normal if-else block as well. That works just as well. It's just a modern JavaScript shortcut syntax. Now save the file and check the browser. You will see the colors alternating. One green, then red, then green again. In other words, the colors are being set according to odd and even indexes. So today we covered quite a lot. Inner text, text content, inner HTML, get element by ID, and get elements by class name. Now let's look one more thing. Get elements by tag name. From the name, it's pretty clear that the method gives us a collection of elements based on their tag name. And what are tag names? If we look at our index.html, we can see tags like div, img, h1, h3, and so on. Suppose we want to work with all the image tags on this page. Very simple. We can write document.getElementsByTagName in the bracket img. Let's put this entire expression inside a console.log and see the result. Alright, now if we save and run, notice something. Our page has exactly two img tags. One is at the very top in the header and the other one is at the very bottom in the footer. If we open index.html and search manually, we will find those two img tags. One in the header and the other in the footer. But here's something to note. The header image tag doesn't have any class, while the footer image tag has a class named footer-logo. Now look at the HTML collection we got in the browser console. Inside that collection, you will see the img elements listed, and for the second one, it shows img.footer-logo. That's basically an identifier. Think about it. You could have dozens of elements. So how do you recognize them individually? That's why class names are also displayed alongside, making it easier to identify elements uniquely. I hope that makes sense. Now let's talk about the most important methods: query selector and query selector all. These two are extremely powerful because they let us select elements just like CSS selectors. In fact, query selector and query selector all are like the combined version of getElementById, getElementsByClassName, and getElementsByTagName. Let's try them out. Suppose in our index.html file, we want to select the elements with the class label using query selector. For that, we write console.log in the bracket document.querySelector again in the bracket .label. Notice here, we are passing .label inside, just like we do in CSS. With getElementsByClassName, we only passed label, but with query selector or query selector all, we use .label, exactly the way we define styles in CSS. Now save and run. You will see that it only gives us one element. But wait, we know there are multiple elements with the class label, right? That's correct. Query selector always returns only the first element it finds with that selector. This is very important to remember. And if you want all the elements with that class, then you will need to use query selector all. Alright, let's copy that console.log line and paste it on the next line. Now replace query selector with query selector all. If you save and check in the browser console, you will see two outputs. The first output is just a single element because that came from query selector. The second one from query selector all is a node list that contains all the elements with the class label. Here's something to note carefully. Query selector all always returns a node list, while getElementsByClassName or getElementsByTagName return an HTML collection. These two might look similar to arrays, but they are actually different data structures. As we saw in an earlier lesson, we can't use the for-each function directly on an HTML collection, but with a node list, you can easily use for-each without any issues. Keep these subtle differences in mind. Alright, now let's move on and see how to query by ID using query selector. Just like I mentioned earlier, we will write the selector exactly the same way we do in CSS. In our index.html file, under the Add New Transaction section, there are some form fields. Among them, I have set the ID amount for the amount field. And for the date field, the ID is date. And intentionally, I have also used the same ID amount again for the category field. Earlier I mentioned that by convention, an ID should only appear once on a page. But technically, if you use query selector all, you can still select multiple elements even if they share the same ID. Let's try that out. Instead of label, let's pass hash amount in the query selector and query selector all. Why the hash? Because in CSS, whenever we target an ID, we use the hash sign. The same rule applies here. For classes, we use a dot, and for IDs, we use a hash. Now save and check the browser console. You will see that query selector gives us the very first element with the ID amount, but query selector all returns a node list containing all the elements that have the ID, even though it's not standard practice to reuse an ID. And this is something you will never get with getElementById. That's why I said earlier, query selector and query selector all are extremely powerful methods. You can also use query selector and query selector all to grab elements by their tag names. For example, instead of hash amount, if we write just A, we will be targeting all the anchor tags on the page. With query selector, only the very first anchor tag gets printed in the browser console. With query selector all, we get all of them. Now let's wrap up this lesson with one more powerful feature. For this, let's go back to our dot level example. So instead of A, we will write dot level. Check the console. You will see the same output as before. Here's where it gets interesting. Just like in CSS, we can use pseudo classes to style specific child or sibling elements. Remember how we do it in CSS? We take the element we want to target, then add a colon, followed by nth child, and inside the parenthesis, we specify which child we want to style. Exactly the same concept applies here too. In the same way, if we write dot level colon nth hyphen child and in the bracket 3 inside query selector, then save the file, you will see that query selector gives us only the third child element. With query selector all, we still get a node list, but it contains just that single element. Pretty interesting, right? That's how powerful this method is, and you can even do more advanced things with it. For example, when improving websites accessibility, we often use attributes like ARIA or data. You might not be very familiar with this at this stage, but let me give you an example. In our index.html, there's an add transaction button. If you check, you will notice that it has a role attribute with the value button. Now, this role attribute isn't something you will see directly in the browser view. It's there to improve accessibility. It helps assistive technologies like screen readers understand that this element is a button. Of course, there can be many other attributes like this. I am just using role as an example here. But the point is, you can use query selector or query selector all to target any attribute in exactly the same way. Alright, now let's remove the label :nth child part. First, we'll put a single quotation, okay? Inside that, right at the beginning, we will use square brackets. This is the convention. And yes, you can do the exact same thing in CSS too. Inside the square brackets, we write the attribute exactly the way it appears in the HTML. In our case, its role is equal to button. So we place that inside the brackets, just like this. Now save the file and check the browser. You will see we have successfully selected the element with role is equal to button. If there were multiple elements with that same role, then query selector all would return all of them in a node list. And that's how you can target any attribute on the page and perform whatever operations you want on it. In the next lesson, we will explore some even more interesting operations. And if you would like to dive into more advanced topics like set attribute, remove attribute, and other kinds of DOM manipulation, along with extra practice, you can check out the DOM manipulation cheat sheet I have posted on our Logic Based Labs page. Go through it, try things out, and practice as much as you can. If you run into any problem or get stuck, feel free to mention our Logic Based Labs page in a public post, and we will do our best to help you out. I will also leave the link to the cheat sheet in the video description. Oh, and please don't forget to follow the Logic Based Labs page for more valuable resources like this. See you in the next one. When working with the DOM, most of the time we deal with the relationship between parent and child elements. That's because the document object model is essentially a tree structure, and inside a tree, there's always a hierarchy. For example, take a look here. We have a div tag, and inside that div, there's an h2 and a ul element. So the children of the div are h2 and ul, right? And this ul itself can have multiple children as well. This is the kind of relationship we'll be working on regularly. To make this kind of work easier, JavaScript gives us some built-in methods and properties. Let me walk you through them one by one. First, let's think about this use case. We have a div, and inside that div, there's an h2 and a ul. So both h2 and ul are children of the div. Then inside the ul, we have multiple li elements, and those are the children of the ul. Makes sense, right? So inside our script.js file, we will write const parent is equal to document.querySelector in the bracket #items. With this line, we have taken the reference of the ul list and stored it in a variable called parent. Now, if I want to get its children, meaning the li elements, I can simply write const children is equal to parent.children. This way, the variable children will hold an array-like collection of all the child elements. Here, children is actually a property of the parent. That's why we can access it using parent.children. And through this children property, we can easily get all the child elements of any parent element. Now, if I do console.log in the bracket children, the console will nicely show a list of all the child elements. And the type of that list will be HTML collection. In a previous video, we saw that an HTML collection looks like an array, but it's not actually an array. However, since it's iterable, we can still run loops on it. If we expand this HTML collection, we will see the children of the parent, meaning the li items. And if you notice carefully, each li element inside our index.html file has a class named transaction-item. If we had simply used query selector all in the bracket .transaction-item to take the reference, we would also get all the items, right? Yes, with query selector all in the bracket dot transaction hyphen item, we could have selected every element with that class, but the problem is it would grab all the elements across the entire page that have the class transaction hyphen item, not just the ones inside our specific UL. Among them, there could be elements that are not actually children of that UL list. Since in our case, we only need the children of the list itself, we will stick to accessing them through parent.children. I hope that makes sense. Now, when we print children in the console, we get an HTML collection, and just like an array, we can also access any specific elements inside it using index numbers. For example, if we want to access the first element, we will write children square bracket 1. After saving the file, you will see in the console that the first element is printed. If we want to access the second element, we will write 2, and that element will be printed. And if we want to access the very last element, inside the square brackets of parent.children, we will write parent.children.length -1. We already know that this is an array. We can find out how many elements it has by using the array.length property. Since parent.children is also an array-like collection, we can use the length property here as well to get the total number of elements. And since arrays are 0 index based, subtracting 1 from the length gives us the last element. Save the file and check the browser. We have successfully accessed the last element. Now, let's move on to accessing the grandparent. For that, we will define a variable called const grandparent. Our grandparent is actually the div element, and it has a class assigned to it. The class name is main-content. So we will write const grandparent is equal to document.querySelector in the bracket dot main-content. And with this, the reference of the div element will be stored inside the grandparent variable. But keep in mind, since we are querying with a class here, we had to use a dot. Earlier, when we used an ID for the parent, we used a hash. These small details are important to remember because mistakes usually happen right in these parts. Now notice this. To get the parent reference, we don't actually need to write the long document.querySelector in the bracket hash items anymore. Instead, we can simply replace it with the grandparent variable. In that case, we will write grandparent.children. Here's the interesting part. Children always return something that looks like an array. Whether there's just one child or multiple, the result will still be in array form. So if I want to access a specific child, I will need to use its index. For example, to grab the UL list, we have to take the second child of the parent because the first child is the H2 element. And for that, we will write children in square brackets 1. Now, if we check the console, you will see output is exactly the same. That means we have successfully accessed all three references, the grandparent, the parent, and the children. Now, let's say you want to go directly from the grandparent to its children. We do have the children property, right? But if the structure is deeply nested, does that mean every time we have to start from the grandparent, then go to its parent, then again to its children? Moving down step by step using indexes? The simple answer is no. Yes, you can technically access children using array indexes, but it's prone to mistakes. And if the number of children is large, that's definitely not a smart approach. The solution is that you can go directly from the grandparent to its child if you want. This is called accessing a descendant. Suppose I want to skip the parent step, meaning I don't want to grab the parent separately but directly access the child from the grandparent. How can we do that? Think about it. Our grandparent variable is actually the div element with the class main-content, right? So the grandparent is this div, and everything inside it is what I want to reach. Basically, I want to move straight to the descendants, and we can easily do that. Earlier, we saw that if I use document.querySelector all, it will return every matching element from the entire document. But if I use grandparent.querySelector all in the bracket dot transaction -item, then I will only get the elements with the transaction item class that are inside the grandparent. And the output will be exactly the same. That's exactly what I wanted to show you. If we want to move to a descendant, we don't have to follow every step in between, one by one. We can directly access it this way. So far, we have been moving from the top down, meaning from the grandparent to the parent, and then to the child. Now let's look at the reverse direction, going from bottom to top. In other words, until now, we were going from parent to child. But what if we want to go from child back to parent? That's what we will explore next. For that, I'm clearing out all the previous code. let's say we create a new variable like this. Const children is equal to document.querySelector in the bracket dot transaction hyphen item. What will this actually grab? Yes, it will grab the list item or li item. And since we used query selector, it will only return a single element. Now, if I want to move forward and get its parent, I will need to grab the ul. To do that, we can write const parent is equal to children.parent element. Just like earlier, we used the children property to access child elements. Here, we will use the parent element property to access the parent. So this way, we can easily get the parent as well. If I now do console.log in the bracket parent, you will see in the browser console that we have got the ul element. Very clear, right? That means we can move upward just as easily as we can move downward. And just like we saw earlier with descendant access, we can also go upward directly if we want. For example, suppose you want to go from a child straight to the grandparent without passing through the parent. JavaScript has a great method for exactly that. If you want to go from a child directly to its grandparent div, and that div has the class main-content, then we will write const grandparent is equal to children.closest and in the bracket dot main-content. This way, we immediately get the reference of the grandparent div. The closest method works a lot like query selector, but the difference is that query selector goes downward from the top, while closest goes upward from the bottom. Starting from the element with the class transaction-item, it keeps moving upward and checks if it finds an element with the class main-content. Now, if I do console.log in the bracket grandparent, you'll see that our parent div shows up right away. And this is what we call the closest ancestor. So, by now, the behavior of the closest method should be clear to you. The last thing left for us to explore is elements that sit side by side. So far, we have only looked upward and downward, parents, grandparents, and children. But now, let's look at brothers and sisters, meaning siblings. Let's say we rename what we previously called children to children1. So, children1 now refers to a specific child. If I want to grab the one right next to it, basically its next brother or sister, I can do that by accessing its sibling. So, if we write const children2 is equal to children1 dot next element sibling, and then console.log in the bracket children2, we will see the children2 element nicely printed in the console. Right now, just seeing it in the browser console doesn't make it very clear which child element we are working with. So let's do something simple. If we apply a little style to children2, it will stand out visually in the browser. For that, we write children2.style.background color is equal to dark green. After saving, you will notice that the second list item, children2, now has dark green text. So we have seen that with siblings. We can use next element sibling to move to the next element. In the same way, we can also go from children2 back to its previous sibling. For that, we will create another variable named previous children and write const previous children is equal to children2.previous element sibling. This gives us the element before children2, which is children1. Now, if we apply previous children.style.background color is equal to dark red, the text of children1 will turn dark red, while children2 will remain dark green just as it was before. Now, everything should be clear. Now I hope you have understood how DOM traversal works. I have shown you each direction step by step, top to bottom, bottom to top, and finally walked you through some useful techniques for quickly navigating between parent and child when there's a hierarchical relationship. Not just parent and child, we can also traverse ancestors, descendants, and even siblings, both previous and next. And the best part is, all of this can be done entirely with vanilla JavaScript. In the past, we often depended on libraries like jQuery for this, but in reality, vanilla JavaScript makes it simple enough on its own. Hopefully, all of these concepts are now crystal clear to you. You will need to keep practicing these DOM traversal concepts again and again because it's very normal to forget them when you're just starting out. That's why I have created a DOM traversal cheat sheet on our Logic Base Labs page. Everything we covered in this lesson, plus a few extra topics you can explore on your own, are all included in that cheat sheet. You can use it as a reference while practicing. The link will be provided in the video description. And one request, please don't forget to hit the follow button on the page. And if you haven't subscribed to the channel yet, please do so. It won't cost money, but will help me a lot to reach wider audiences and spread my valuable learning resources. Now, let's move on to the next lesson. In the previous lessons, we learned how to select different elements from the DOM and how to traverse from one element to another. Now, we are going to see how to actually manipulate the DOM, meaning how to create new elements, modify existing ones, or dynamically insert new content inside them. In this part, we will practice all of these tasks hands-on. Let's first see how to create a brand new DOM element. In other words, how can we dynamically build an element ourselves? Suppose we want to create a div. Then we will write const div element is equal to document.createElement in the bracket div. The function name createElement is very straightforward. It literally creates whatever element you specify. If you want a div, pass in div. If you want a paragraph, use p tag. And if you want to add a span, then use span. So basically we can create anything we want. I just created a div element. Now, if we write console.dir and pass that div element inside it, then check in the browser console. What will happen? We will see all the methods and properties of that div element. In other words, we can explore everything that can be done with that element and all the properties it comes with. Now, we can also set different properties on this div element. For example, a div usually has a class. We can add a class to our div element as well. To do that, we use div element.className. Since div element is an object, it comes with many properties and class name is one of them. If we assign it a value like red, then the class name of the div element will become red. Now, you might be wondering, why are we writing .className here? Notice carefully, this is JavaScript code, whereas index.html is plain HTML. In HTML, we just write class, not class name. But since we are working with JavaScript, div element is actually an object. And for that object, a property called class name is already defined. That's why we must use class name instead of a class. If you just write class, it won't work. Those of you who work with React already know that in JSX, we have to use class name instead of class. That's because JSX isn't really HTML. It's actually valid JavaScript code. So the syntax follows JavaScript rules. When JSX is transpiled into JavaScript, it keeps class name. And later, when that JavaScript finally renders into real HTML, it gets converted into class. Now let's add another property, which is ID. We can assign an ID directly as a property, or we can also set it as an attribute. To set it as an attribute, we use div element.setAttribute. In other words, setAttribute is a method of div element that allows us to add any attribute we want. In the setAttribute method, the first argument is the name of the attribute, and the second argument is its value. For example, if we want to set an ID, we will write div element.setAttribute in the bracket ID in the first parameter, comma, and the second parameter red. This means our div element will now have an ID of red. In the same way, we can add more attributes if we want. For instance, let's say we want to set an attribute called title. In that case, we will write div element.setAttribute in the bracket first parameter title, comma, and as a second parameter, we can write red div. Here, the attribute name is title and its value will be red div. Alright, so far we have created a div element, set some attributes on it, and even added a class. But notice carefully, we still haven't added this div element to our HTML. Right now, it only exists as a dynamically created element inside JavaScript. We can inject this div element into our index.html whenever we want. If we want it to actually appear in the UI, we must add it to the HTML, and we can place it anywhere, inside balance summary, container, sidebar, header, or even directly into the body if we like. For example, let's say we want to inject our div element dynamically as the very first child inside the div called balance-summary. To do that, the first thing we need is a reference to balance-summary. Without that reference, we won't even know where to inject it. In the previous lesson, we already saw how to take references of different elements. We will do the same here. So we will write const container, meaning we have named our variable container, Then we assign it like this: document.querySelector in the bracket dot balance hyphen summary. Since balance summary is a class name, we must use a dot inside query selector, like dot balance hyphen summary. That way, the reference of balance summary will be stored in our container variable. Now the question is, where exactly do we want to inject our element? Inside balance summary, there's currently an h3 element as the first child. We want to insert div element before that h3. For that, we will also need the reference of the h3 element. So we will define a variable named h3 element, like const h3 element. Then we will write container.querySelector, since we want to query inside the container. Inside query selector, we will pass h3. This will give us the reference of the first h3 element inside container. We have got the reference of h3 element. Now our goal is to inject div element right before it. For that, we will use the container object. Every HTML element object has a method called insertBefore. Using this method, we can place our div element just before h3 element. So we will write container.insertBefore. This method takes two arguments. The first argument is the element we want to insert, and the second argument is the element before which we want to insert it. In this case, the first argument will be div element, since that's what we are inserting. The second argument will be h3 element. So our div element gets added right before the h3 element. After saving the code and reloading the browser, you won't see anything directly in the UI. But if you open Chrome DevTools and inspect the DOM, you will notice a new div has been created just above the h3 element. It already has both ID and class set to red. However, since the div is completely empty, with no height, no width, and no children, it appears invisible or blank in the UI. Alright, to make it visible in a nice way, we can do a simple trick. Since we have already added a class to our div element, we can now go into the style.css file and write some CSS for that class named .red. So let's open style.css and at the bottom add a few lines of style code. In short, we created a class called .red where we set height to 100 pixel, width to 200 pixel, and applied a background color so that our div element becomes clearly visible. Now when we reload the page, we can see a bright red box right above the h3 element. That means we have successfully created our div element dynamically and placed it exactly in the position we expected. Now let's look at something interesting. Earlier we saw how to insert an element as the first child of a container. This time we will learn how to insert an element as the last child of a container. It's very simple. We can just use the appendChild method of container to add div element at the very end. For that, we write container.appendChild in the bracket div element. After saving and running the code, you will notice that div element has been added as the last element of the container. So the summary is, using appendChild, we can inject a new element at the very end of a container. While using insertBefore, we can place a new element before any specific target element. Well, we have just seen how appendChild works, but there's another version called append. Both serve almost the same purpose, but there are some differences in how they are used. Let's go through them step by step. If we replace container.appendChild div element with just append in the bracket div element, then after loading the page, the output will look exactly the same. So the question is, where's the difference? To understand that, instead of div element, let's try append in the bracket hello world. Now check the browser. You will see that hello world has been inserted right at the end of the container. But if we try to do the same thing with appendChild, like appendChild in the bracket hello world, it won't work. That's because appendChild can only insert DOM elements, not raw text directly. On the other hand, the append method can insert both DOM elements and text nodes. Notice this time it didn't work. Inside the browser console, you will clearly see an error. That's because appendChild only expects an HTML element and can only inject that. But append works a little differently. It can take both HTML elements as well as text or nodes. That was the first key difference. Up until now, we have only been passing a single argument. But with append, we can pass multiple children elements or nodes at once. For example, inside container.append, we can first pass div element, then directly add hello inside the p tag. And along with that, we can also add document.createElement in the bracket span, separated by commas. Now, when we save and reload the browser, you will notice that with just one append method call, all of them rendered together at the same time. But if we try the same example with append child, meaning we replace append with append child and pass 3 arguments, it won't work. Since the first argument is div element, which is a valid element, only that first one will show up in the browser. The rest won't appear at all. That's because append child can insert only a single element. It doesn't accept multiple arguments. On the other hand, append can insert multiple elements or nodes at once. That's the second difference. The next difference is in return values. To check this, we will store the return value of append child in the bracket div element in a variable named a, and the return value of append in the bracket div element in another variable named b. Now, if we log a and b in the console, you will notice something interesting. The return value of append child is actually the element itself. In other words, append child returns the same element it just inserted. But in the case of append, the b variable will print undefined, meaning the append method doesn't return anything. So, in summary, these are the 3 main differences between append child and append. Depending on our needs, we can choose whichever method fits best. Hopefully, everything we covered in this lesson is now crystal clear to you. See you in the next lesson. In this lesson, we will talk about different types of event listeners. But first, what exactly is an event listener? Think of it this way. Whenever we interact with a web browser, like when we design a web page, we need a way to handle all sorts of user interactions. For example, if a user clicks a button, that's an event. Not just a button, they could click anywhere on the page, perform an action with the mouse, or type something on the keyboard. Each of these actions is considered an event, and an event listener is what allows us to respond to those events. So, whenever a user performs an action, there are already predefined events for each of those actions. The moment that action occurs, an event is automatically generated, and we can choose to listen to that event. This process is what we call event listening. For example, let's say a user clicks on our Add Transaction button. As soon as that happens, JavaScript automatically triggers a click event. If we listen to that button's click event, we can capture and use a lot of useful information from that event. Let's make this clearer with example. Suppose we want something specific to happen when someone clicks on the text expense tracker. Here, the click is the event, and the something that happens is what we call the callback. We will learn more about callbacks in detail soon. First, we need to grab the expense tracker element. If we look at the HTML, you will notice it's inside an h1 tag with a class called title. We will use that class to select the element. So we write const header element is equal to document.querySelector in the bracket dot title. Now we have the element stored in a variable. The next step is to attach an event listener to it, so that whenever someone clicks on this text, the event fires and triggers the action we want. So what we need to do is write header element dot add event listener. This is a built-in JavaScript function that lets us attach a listener to a specific element. Since it listens for events, it's called an event listener function. In the first parameter of add event listener, we specify which event we want to listen for. JavaScript has many types of events, and I will show you a full list later. Among them, the most common one is click. That means whenever someone clicks on the expense tracker text or that element, the click event will fire. In the second parameter, we define what should happen once the event occurs. In other case, we need to decide what will happen after the click. For that, add event listener takes a function, and that function is what we call the callback function. So, in the second parameter, we pass a function. Here, we can use either an arrow function or a normal function. It doesn't matter. Whichever way we write it, that function automatically receives a parameter called the event object. You can name it event or give it any name you like. Now suppose we write console.log in the bracket event. After saving the code, notice that nothing happens if you click anywhere else on the page. But the moment you click on the expense tracker text, the console will instantly log an event object. This object is actually of type mouse event. If you expand it, you will see it contains many properties like element path, page X, page Y, offset X, offset Y, and many more. And the interesting part is we can use any of these properties to do whatever we need. And that's basically the core process of catching or listening to an event. Exactly. Depending on which event we are listening to, the data inside the event object will change. For example, since we listened for a click event on the H1 element, we only got click-related information. But if we were listening to an event on an input element, the data would be completely different. The point is, events come in many variations, and each one allows us to handle different kinds of interactions. So now, let's try out a few events in practice and see how they work. We just tried out the click event. Now let's test the double click event. For that, instead of writing click as the first parameter of add event listener, we will write DBL click. That means double click. Now if I click once on the H1 element, nothing happens. But the moment I double click, the event is triggered right away. That's the double click event. Next, let's look at mouse events. First take mouse down. The moment I press down on the H1 element with my mouse, meaning I hold down the click, the event is logged immediately. If we replace mouse down with mouse up, the behavior changes. This time, when I click and keep holding, nothing happens. But as soon as I release my finger, the event is logged. If I press and hold again, still nothing happens. But the moment I let go, the log shows up. That's because the mouse up event fires only when the mouse button is released. In the same way, there are plenty of other mouse events. For example, let's try mouse enter. Save the code and now notice, whenever I move the cursor inside the H1 element, the event fires immediately. No click is needed. Just moving the mouse into the element is enough. Since there's a mouse enter, there's also a mouse leave. Update the event name and test again. This time, when I move the cursor inside the element, nothing happens. Clicking or double clicking doesn't trigger anything either. But the moment I move the cursor out of the element, the log appears. That means the mouse leave event only fires when leaving the element. There's another one called mouse hover. This one fires whenever the mouse goes over the element. So, as soon as I move my cursor onto the H1 element, the event triggers right away. The opposite of mouse over is mouse out. Here, if I keep the mouse on top of the element, nothing happens. But the moment I move the cursor out of the element, the event logs immediately. Now, you might be wondering, aren't mouse leave and mouse out the same thing? And similarly, mouse enter and mouse over also seem to behave the same way. So why do we have 4 different events? The truth is, there's a subtle difference between them. To explain that properly, we will need an element that has child elements inside it. If you check the index.html file, you'll find an element called balance-summary. Since it contains multiple children, it's the perfect example to demonstrate this difference. But to make the visualization clear, let's first add some styles to the balance summary class. Open the styles.css file and find the section where the balance summary class is defined. Now, let's add a border to it. Set the border width to 1 pixel and the color to light green. After saving the code, check the browser. You will see a green border around the balance summary div element. Next, let's move over to script.js. Earlier, we used query selector with the title class, but now replace that with balance-summary. Then in add event listener, set the event to mouse enter. After saving the code, when I move the mouse into the balance summary div element, notice that the log appears only once. Even if I move the cursor around inside that div, over total balance, total expense, or total income, no new logs show up. It only fired the first time I entered the div. Makes sense, right? Now let's replace mouse enter with mouse over in add event listener. This time, the moment I take the mouse over the balance summary div, one log appears just like before. But now, whenever I move the mouse over any of its child elements, new logs keep appearing every single time. So the key difference is this. With just one mouse over event listener on the parent, not only does it trigger when hovering over the parent, it also fires again whenever the mouse goes over its child elements. So the main difference is this. Mouse enter fires only once when the cursor enters the parent element, while mouse over fires not just on the parent but also every time the mouse goes over its child elements. Up to this point, we have tried out different kinds of events, and these are the most common ones. But apart from these, there are other important events that we often need to use. especially when working with input fields. Inputs usually require handling multiple types of events. Let's check out some input field events now. Our page already has several inputs, but for this example, we will use the category input field. If we look at the index.html file, you will see that this category input field has an ID attribute named category. So inside query selector, we will write #category. And instead of naming the variable header element, let's rename it to input element. Now, for this input element, the event we will use is key down. This is a keyboard event, which means every time I press a key, an event immediately logs in the console. It works very much like the mouse down event, but if we replace the key down with key up. Now imagine I press a key inside the category input field but don't release it yet. Notice that nothing logs in the console while the key is still pressed down. The moment I release the key, the log appears. That means the key up event fires exactly when the key is released. So we have seen both key down and key up. Alongside those, there's another one, key press. It works in a similar way, but the difference is that the moment you press a key, the event fires right away. It doesn't matter if you keep holding the key or release it. Just pressing is enough to trigger the event. Next, we have another important event, focus. This time, put focus as the event inside add event listener. Now, whenever you click on the input field or place the cursor there, the event will fire immediately. Often, we need to detect cases where someone was typing in an input field, then clicked away outside and later came back again. For example, maybe we want to clear the previously entered text whenever they return. That's something we can easily manage using the focus event. The exact opposite of focus is the blur event. This fires the moment you click outside or move away from the input field. Alongside that, there's another interesting event, cut. Suppose you type something in the input field, then select it and cut it. Instantly, the cut event is triggered. You can even build some fun logic around this. For example, if someone tries to cut or copy text, you could show a playful message like, "Are you trying to steal something?" And of course, since there's a cut event, there's also a paste event. The moment you paste something into the input field, the event fires and gets logged. This can actually be really useful in practice, especially for security reasons. For instance, in password fields, we might want to prevent users from copy-pasting their password. By detecting the paste event, we can easily restrict that behavior. See how beautifully these event listeners work. Another very useful one is the input event. This fires whenever there's any change inside the input field. That means if you type a character, cut text, or paste something, no matter what kind of change happens, the input event triggers right away and logs in the console. Exactly like this, we can work with many different events beyond just inputs. Now, let's move on and explore form events. In our case, we have an add transaction button, which is actually inside a form. Instead of targeting just the button, we can select the entire form element and listen for its submit event. So, inside query selector, we will write form. That way, the form gets selected. Instead of input element, let's name the variable form element. Next, in add event listener, we will set the event to submit. That means now, whenever the form is submitted, the event will fire. Now suppose we submit the form. You will notice the log appears in the console but disappears almost instantly. Why does that happen? Because as soon as the form is submitted, the browser reloads the entire window. That's the default behavior of an HTML form submission. Submitting a form always reloads the page. But in modern web applications, we usually don't want that to happen. Instead, we need to stop this default behavior. That's why the event object we get inside the callback function has a method called preventDefault. Calling this stops the browser from reloading the page after a form submission. So we simply write event.preventDefault. With that, the default reload behavior is blocked. Now, if we console.log event after submitting the form, you will see the page no longer reloads and the event object appears nicely in the console. If we use the target property of this event object, we actually get the entire form element itself. That's because target tells us which element the event was triggered on. And in our case, that's the form element. Exactly, the event object comes with lots of methods and properties that we will explore step by step. And using event.target, you can grab any input element inside the form, even access its value directly. For example, Say, in the form you want to get the values of type, amount, date, or category fields individually. In that case, you can write event.target.amount.value. Now, if you save the code, type something into the amount field, and submit the form, you will see that exact value logged in the console. Makes sense, right? The reason we can access amount like this is actually pretty straightforward. Remember, I mentioned earlier that every element in HTML is treated like an object. When we use event.target, we are getting the whole form element. And since the form contains multiple input fields, the form itself acts as the parent object, while the inputs are its children. That's why we can simply use a dot after event.target to directly reach a specific input field. Now the question is, where did we get the name amount from? If we check the index.html file, you'll see that the amount input field has a name attribute. And it's exactly that name attribute which lets us access it using event.target.amount. In the same way, the date field has a name attribute called date, and the category field has the name category. These name attributes are what actually become available as properties of the form element. So, if we want to retrieve the values of all the input fields, we can simply use these properties one by one. For example, we can write console.log in the bracket event.target.date.value and console.log in the bracket event.target.category.value. Now, if you save the code, fill out the form, and submit it, you will see that all the input values, including date and category, are neatly logged in the console. And this is basically how we handle form data. Of course, there are plenty of advanced techniques for this, but as a beginner, learning these basics is more than enough. Before wrapping up, as I mentioned at the beginning of the video, I will share a full list of events. For that, you can follow a specific page on W3 Schools. The link will be in the video description. Each event there is explained really well. You can spend some time experimenting with them one by one and see exactly how each one works. That's all for my discussion on event listeners. Next, we will move on to our final lesson, where we will build a small project to wrap up this entire DOM series. Now it's time to put everything we have learned about the DOM into practice by building a real application. This way, you will get hands-on experience similar to working on an actual project. We are going to build an expense tracker application. The purpose of this app is to keep track of our daily income and expenses. If you look at the UI, on the left side, there's a form called Add New Transaction. Inside this form, you will find a few input fields: type, amount, date, and category. By filling out this form, we can create a new entry for either income or expense. Above the Add New Transaction form, there's a balance summary section. Here, we can see the total balance, the total income, and the total expense. In other words, a quick summary of everything in one place. On the right side, there's the transaction history section. Items or rows with green icons represent income, meaning money has been added to the account. Rows with red icons represent expenses, meaning money has been spent. If you compare this with the Add New Transaction form, you will notice that the type field in the form lets us choose between income or expense. That same choice is reflected in the transaction history, where the green or red icon appears based on the selected type. The amount field also directly shows up in the transaction history. If it's an expense, the amount appears in red. If it's income, it appears in green. At the same time, that amount updates the balance summary so everything stays in sync. The form also has a date field, and that date is displayed directly in the transaction history. Finally, there's the category field, where we specify which source the income or expense belongs to. For example, for income, we might write salary or profit, and for expenses, we could write rent or electricity. At the very end, each transaction has a small cross button. Clicking on it removes that transaction. Notice that as soon as you delete one, it disappears from the transaction history. And at the same time, the balance summary updates instantly. If you delete multiple items, both sections adjust right away. So this is our project, a very simple CRUD application. Here we are creating new transactions, reading and displaying them in the transaction history, and also deleting them if we want. The whole process is simple and straightforward. Now, if we talk about the technical flow, the first thing we will do is listen to the form's submit event. Whenever someone submits the form, a new transaction item will be added instantly to the transaction history. At the same time, the balance summary will update with the new values. So let's dive into the code. First, we will open our script.js file. According to our plan, the very first step is to define some variables. First, open the index.html file. Inside it, you will find the form element. And notice that this form has an ID called transaction form. Since we need to listen for the form's submit event, the first step is to grab a reference to it. To do that, we will write const transaction_form is equal to document.getElementById transaction form. Here, we are simply selecting the form element by its ID, which is set to transaction form. Next, when the user submits the form, we will take their input and display it in the transaction history section as a new list item. To do that, we need a reference to the parent element, which is the UL. So, we will write const transaction_list is equal to document.getElementById in the bracket transaction list. If you open the index.html file, you will see that the UL element already has this ID, transaction list. Now, along with displaying the new transaction in the transaction history, we also need to update the balance summary. If we check index.html, we will see that in the balance summary section, the element showing total balance has the ID total balance. The element for total income has the ID total income, and the element for total expense has the ID total expense. So, inside our script.js file, we will create references for this as well. We will write const total_balance is equal to document.getElementById in the bracket total balance. Then const total_income is equal to document.getElementById in the bracket total income. And finally, const total_expense is equal to document.getElementById in the bracket total expense. That way, we now have all the references we need. I hope this part is clear. Our next step is to listen for the form's submit event so that whenever someone submits the form, we can create a new transaction item. Let's do it exactly the way we practiced in the previous lesson. Here, we will write transaction_form dot add event listener. Which event should we listen to? Since we want to capture the form input values when it's submitted, we will listen for the submit event. So the syntax will be transaction_form.addEventListener in the bracket. In the first parameter, we will write submit, and the second parameter we will write a function, and which can take an event as a parameter. This callback function receives the event parameter, and inside that we can access the form, its target elements and their values. Inside the callback, the very first thing we will write is event.preventDefault. Remember from the earlier lesson, by default, when a form is submitted, the page reloads. But we don't want the page to reload on submission. That's why we use preventDefault to stop that behavior. Keep in mind, preventDefault isn't limited to forms. It can block the default behavior of any element. For example, if you apply it on an input field, you will no longer see the typed text appearing there. Now, let's test whether our form is actually being submitted. We will write console.log in the bracket hello world. Save script.js, reload the page in the browser, and submit the form by clicking the Add Transaction button. You will see hello world printed in the console, which means everything is working as expected. Next, instead of logging that message, we will extract the values of the input fields using event.target. For example, we will write const type is equal to event.target.type.value. Here, event.target refers to the form, and from inside it, we are accessing type.value and storing it in a variable called type. You might be wondering, how did we get the type property inside event.target? To understand that, let's go back to the index.html file. There you will see that inside the form, we have a select option element. As you already know, select option tags are used in HTML to create drop-down menus. And we also have one in our UI. If you look closely, you will notice that this element has a name attribute and its value is type. That's why when we access event.target.type, it works perfectly because event.target looks at the form's fields by their name attributes. In the same way, if we want to get the value from the next input field, amount, we will use event.target.amount.value. This logic applies to all the fields in the form. So let's go ahead and add those inside our script.js file. right under the type variable, we will write const amount is equal to event.target.amount.value. With this, we are able to fetch the value entered in the amount field. Next, for the date field, we will write const date is equal to event.target.date.value. And finally, for the category field, const category is equal to event.target.category.value. That way, we now have references to all our input field values. To make sure everything is working, let's quickly verify in the browser. At the bottom of the code, we will add console.log type amount date category. Then save the file, reload the browser, fill in some data in the form, and click the Add Transaction button. If you check the console, you will see all the entered values printed correctly. That confirms everything is working as expected. Now our task is to insert a brand new item inside transaction_list. For that, we will write a separate function whose job will be to take the values submitted by the user and build a new list item out of them. Let's write that function. Just above transaction_form.addEventListener, we will add function updateList. This updateList function will receive type, amount, date, and category as parameters. For now, we haven't called updateList yet, but later, inside the form submit callback, we will call it and pass the input values as arguments. Simple. Inside updateList, we will use document.createElement to create a set of new elements. But which ones do we need? Before writing the code, we need to understand the role of updateList function. The job of updateList is to add a new li element inside the transaction history section's UL. That li will contain all the details of the user's submitted data. If you open index.html and look inside the transaction list UL, you will see what a transaction item looks like. Each item is an li with the class transaction-item. And inside it, there are several nested div elements. That's exactly what we will rebuild using JavaScript. So inside updateList, we will start with const item el, that means item element in short, is equal to document.createElement in the bracket li, since we first need to create the li element. Then for the icon, we will add const icon el is equal to document.createElement and in the bracket div. Next, we check index.html again. We will notice that we also need a transaction-details div, and inside that, two more divs, one for transaction-name and one for the date. So we will create those two. Const details el is equal to document.createElement in the bracket div. Const name element is equal to document.createElement in the bracket div, and const date el similarly. Here you will notice a small convention. Item el, details el, name el, date el all have el at the end. This is just for clarity to remind us that these are DOM elements. It's not required, but it helps keep the code easy to read and understand. You can say it's just a best practice. We still need to create a couple more elements. If you check index.html again, you will see each transaction also has a transaction-amount element along with a transaction-delete button. So we will build those two. Inside script.js, we will write const amount el is equal to document.createElement in the bracket div, and const delete el is equal to document.createElement in the bracket button. Since we are making a button, we specially pass button into createElement for delete el. That part should be clear. Now you might be wondering, why did we create a separate updateList function at all? Couldn't we have just written the element creation code directly inside the submit callback? And honestly, that's a very good question. But here's the reasoning. Yes, we could have written all the document.createElement logic directly in the submit callback. But the reason we don't is because we want our code to remain clean, readable, and maintainable. By splitting things into separate functions or modules, the code becomes much easier to read, understand, and modify later on. Think of it like this. In your kitchen, you have all sorts of jars and spices. You could keep them on your computer desk if you wanted. It wouldn't technically break anything, but we all know that's not the right place. The computer desk is meant for working, not storing spices. In the same way, the job of the submit callback is to handle the form data, not to worry about rendering the UI. That's why we have created a separate function whose sole purpose is rendering the UI. The submit callback will just call that function and let it handle everything else. So, update list is dedicated to rendering and the submit handler is dedicated to managing the form input. This separation keeps everything neat and organized. I hope that clears things up. And if you still have confusion, you can always post on our Logic Based Labs page and tag us. We will do our best to help solve your issue. Alright, let's get back to the actual work. Inside the update list function, the next step is to add classes to each DOM element we have created, just like they are defined in our HTML. Along with that, we will also set the values coming from the parameters. First, for item.el, we will add the class transaction-item because this class ensures it gets the right styling. So, we will write item.el is equal to classList.add in the bracket transaction-item. Here, we are using a new property called classList, right? Earlier, in a previous lesson, I showed you another way to add classes. And yes, that method still works. But classList.add is the cleaner, more standard approach. So this is what we will use going forward. Now, let's add the remaining classes following our HTML structure. For the icon element, we will write icon.el.classList.add in the bracket transaction-icon. Then detailsel.classList.add in the bracket transaction-details. Next, nameel.classList.add in the bracket transaction-name. For the date element, we will add dateel.classList.add in the bracket transaction-date. For the amount element, we will use amountel.classList.add in the bracket transaction-amount. And finally, for the delete button, we will write deletel.classList.add in the bracket transaction-delete. If you want, you can open index.html and cross-check each class name side by side to make sure everything matches. Now that the classes are in place, the next step is to set the actual content. First, let's set up the icon. Which icons do we need? If we look at the browser, you will notice that green circles have an upward arrow, while red circles have a downward arrow. That means we need to add them conditionally. So, in our code, we will set icon.el.innerText. You already know how inner text works. We covered it in an earlier lesson. Now we will check if the type is income, we will display an up arrow, otherwise a down arrow. Using the ternary operator, that becomes icon.el.innerText is equal to type triple equal to income question mark upper arrow colon down arrow. A simple if-else logic written in a compact way. Next, we will conditionally add a class to icon.el. If the type is income, we will add the income class. If it's expense, we will add the expense class. So, we will write icon.el.classList.add in the bracket type triple equal to income question mark income colon expense. This is exactly how it was in the HTML, where transaction-icon had either income or expense as an additional class. After that, we'll set the name.el content. Since this comes directly from the category field, we will write nameElement.innerText is equal to category. Now for the date, we will set dateel.innerText to a formatted date using JavaScript's date object. So, dateel.innerText is equal to new date in the bracket, the date parameter, dot toLocalDate string. The first parameter will have a string, en-us. Then an object with these key value pairs, month, colon, short, day, colon, numeric, and year, colon, numeric. This way, the date appears in a neat, natural format like, for example, October 27, 2025. Date is a built-in JavaScript feature with lots of methods. And yes, sometimes it can be confusing. That's why we have created a date methods cheat sheet on the Logic Based Labs page. It's a handy reference for situations like this. Next, we will handle the amount. For amountel.innerText, we will conditionally add a plus or minus sign based on the type. If it's income, we prefix with plus, otherwise minus. Then we add a $sign and the amount. So the code looks like this. AmountTL.InnerText is equal to if type is equal to income, then plus, else minus. Then we can concatenate with a $sign and then an amount. After that, we will also add a class to AmountTL, just like with the icon. Income items get the income class and expenses get the expense class, so that the text color is styled differently. If you open index.html, you can see that the div with transaction-amount class also has income class. So we are logically adding that income and expense classes. There's one last step left. We will set a cross symbol as the inner text of the delete button. For that, we will write deletel.InnerText is equal to a cross. That means we can write X. Now, all that's left is to append these elements together, making sure the parent-child relationships are followed exactly as in the HTML. If we open index.html and look inside a transaction-item, we will see the structure clearly. First comes the icon, then its siblings, transaction-details, transaction-amount, and the transaction-delete button. Inside transaction-details, there are two children, transaction-name and transaction-date. We need to recreate this exact structure in our DOM. So first, we will append the children into detailsEL. detailsEL.appendChild in the bracket nameEL. Similarly, detailsEL.appendChild dateEL. Now we will assemble the full item step by step. itemEL.appendChild in the bracket iconEL. Then itemEL.appendChild in the bracket detailsEL. Similarly, itemEL.appendChild amountEL and itemEL.appendChild deleteEL. At this point, itemEL represents a complete row, exactly like a transaction in our history. The first step is to place this row into the transaction history. For that, we will use transaction_list.prepend and in the bracket itemEL. Remember, prepend works just like append or appendChild, but with one difference. Append adds new elements at the end of the list, while prepend adds them right at the beginning. So now you have seen the full flow. But will this work if we submit the form right now? Not yet, because so far we have only written the logic for creating elements. We haven't actually called update list anywhere. And when we call it, we also need to pass the form input values as parameters. So let's go ahead and do that. Inside the form's submit callback, we have now called the update list function and passed the arguments in the correct order: type, amount, date, and category. Everything looks good so far. So let's test it in the browser. We enter some values in the form. Then click Add Transaction, and there it is. A brand new transaction row shows up immediately. Now let's try adding some expense data. Perfect. The expense is added too. Notice how the expense shows a red icon, while the income shows a green icon. Congratulations, we have made solid progress. There's just one small thing to fix. In index.html, we still have those hard-coded transaction-item examples. We should remove them because we only want our transaction history list to show dynamically created items. Another detail to notice: after we add a new transaction, the form fields still keep the old values. For a better user experience, the form should reset after submission. To do that, right after the line where we call update list, we will add transaction_form.reset function. The reset method is specifically for forms and it clears all the fields instantly. Simple JavaScript. Let's try again. We add a new transaction. This time, as soon as the form is submitted, it resets itself. Perfect. Now, we still have one important task left: calculating the balance summary and updating it dynamically. And for that, we have two possible approaches. Exactly. In the first approach, we would have directly read the current values of total_balance, total_income, and total_expense using inner text or text content. Then adjusted them whenever the form was submitted. But as we discussed, this is risky because if someone manually edits those values from the browser's DevTools, all our calculations would go wrong. That's why the second approach is much safer and more reliable. Here, we will maintain a proper array of all transactions. And every calculation will be based on that array instead of what's currently displayed on the screen. So first, at the very top of our script.js, we define an array. Let all underscore transactions is equal to a blank array. Then inside the submit callback, right after we call update list, we will save the form input data into this array. We will store it as an object. All underscore transactions dot unshift, and in the bracket type, amount, date, category. We are using unshift here because we want the most recent transaction at the start of the array. Remember, push would add to the end, but unshift adds to the beginning. Now, all our transactions are stored in the all underscore transactions array as objects. With this in place, we can move on to writing our calculation logic. For that, we will create a function called updateBalance. Function updateBalance. Inside this function, we will first declare three variables: income, expense, and balance, and initialize them to 0. Let income is equal to 0, let expense is equal to 0, and let balance is equal to 0. Next, we will loop through the all underscore transactions array using for each. All underscore transactions dot for each. We will get each transaction as transaction, and in the callback function, we will return something. Here, transaction refers to a single object from the array containing type, amount, date, and category. That means for every iteration, we will have direct access to transaction.type and transaction.amount, which we can then use for our calculations. Now the question is, how do we update income, expense, and balance inside this loop? Now we will use an if-else condition to check the type property of each transaction object. If the type is income, then we will add the transaction amount to both the local income variable and the balance variable. If it's not an income, meaning it's an expense, then we will add the amount to the expense variable and subtract it from the balance. So here's what we do. Inside the if condition, we check transaction.type is equal to income. Then within the curly braces, we write income plus is equal to parse float in the bracket transaction.amount, and right after that, balance plus is equal to parse float in the bracket transaction.amount. Notice here, I have written income with a capital I. That's because from the select option element, the value we will get is income with a capital I. Since JavaScript is case sensitive, we have to write it exactly the same way. Also, I have wrapped transaction.amount with the parse float method. That's because whenever we fetch a value from the DOM, it always comes back as a string. And if you add a string to a number, instead of doing a proper calculation, JavaScript will just concatenate them together. To avoid that, we use parse float so the string is converted into a number before adding it up. In the else clause, we write expense plus is equal to parse float in the bracket transaction.amount and balance minus is equal to parse float in the bracket transaction.amount. This way, when the for each loop finishes, we will have the actual calculated data for income, expense, and balance. The only thing left is to update those values in the DOM. Since we already have references to total balance, total income, and total expense, we can simply update them using inner text. We write total underscore balance dot inner text is equal to a $sign and then plus balance. Here, we have added a $sign before the balance just to make it look nicer. Then we write total underscore income dot inner text is equal to $ plus income. And finally, total underscore expense dot inner text is equal to $ plus expense. The last step is to call the update balance function. So inside the submit event callback, we call update balance right after storing the transaction. We don't need to pass any arguments while calling it because all the variables this function needs are already in the global scope, so it can access them directly. Now, let's go back to the browser, reload the page, and start entering some data. First, I selected type as income, entered 1000 as the amount, picked a random date, and wrote salary in the category field. Then I clicked on the add transaction button. Notice how a new item instantly appeared on the right side. And on the left side, the balance summary updated correctly. In the same way, I added another expense entry. This time, I entered 50 as the amount, wrote rent in the category field, and submitted it. See that? Everything is working perfectly. The balance summary updated just as expected. So far, everything is working just the way it should, but there's one small improvement we can make. Try refreshing the page again. In the balance summary section, we will notice it's still showing some hard-coded values from our HTML. To make it look more authentic, we can reset those values to 0 instead of keeping the preset numbers. So, open the index.html file, then go to the balance summary section, update the total balance value to 0. And in the same way, set both the total income and total expense values to 0 as well. Now there's one more feature left to build, the delete option. Let's work on that. For this, we will go back to the update list function. If you look there, we already created a delete button called delete EL. What we want now is that whenever someone clicks on delete EL, that specific transaction item gets removed. To make that happen, we will need an event listener. Inside the update list function, we will attach a click event listener to the delete button by writing deletel.addEventListener in the bracket, first parameter click, comma, delete transaction. Here, the callback for the click event is a function named delete transaction. That means whenever the delete button is clicked, the delete transaction function will run, and this function will handle how the transaction is actually removed. We haven't written the delete transaction function yet, right? So outside the update list function, we will define it as function delete transaction. Since delete transaction is called from the click event listener, it will receive the event object. So inside the delete transaction, we will have access to that event. Now the question is, how will delete transaction actually work? How do we remove the item? Since we have both delete transaction and the event object, we can use event.currentTarget to access the delete button itself. From that button element, we can use the closest function to get a reference to its parent transaction-item element. Then, by simply calling remove on that item, we can directly delete the entire transaction from the DOM. So, inside delete transaction, we will write const btn, that means button, is equal to event.currentTarget. That gives us the button. Then we will get the parent list item by writing const itemel is equal to btn.closest in the bracket dot transaction hyphen item. Now itemel is the li element of the transaction where the user clicked the delete button. To remove it from the DOM, we just call itemel.remove function. Let's save the file and test this in the browser. We add a few transactions and click the delete button. See, the transaction is deleted cleanly. If we delete another one, it works the same way. Every time we click the delete button, the corresponding transaction disappears. But there's still a problem. The balance summary is not updating. So the next question is, how can we fix that? If we think about it, in order to update the balance, we also need to remove that specific transaction from the all underscore transactions array, right? The challenge is when we delete an item from the list, how do we know which element in all underscore transactions it corresponds to? To solve this, we will get the index of the deleted item from inside transaction underscore list. Once we have that index, we can remove the same transaction from the all underscore transactions array. Let's do that. Inside delete transaction, after we use btn.closest to get itemel, we will calculate its index like this. Const index is equal to array.from in the bracket transaction underscore list dot children, and then the index of item element. Here we are using array.from to convert all the children of transaction underscore list into an array. Since we now have an array, we can easily use index of to find the position of itemel. That means we can directly get the index of the row we are deleting without any hassle. I am not going into detail about array.from or index of here, since I am assuming you already know how these work. Using the index we just found, we will remove the corresponding object from all underscore transactions with splice. All underscore transactions dot splice in the bracket the index, comma, and the second parameter 1. This deletes the targeted transaction from the array. Right after that, we will call update balance function. That function will recalculate everything using the updated all underscore transactions array and refresh the balance summary accordingly. So let's test it now and see if everything is working properly or not. I have already added a few transactions to the transaction history. Now let's start removing them one by one. Notice how every time I remove an item, the balance summary updates immediately. And if I delete all of them, the total expense resets to 0, while total income and total balance adjust correctly to match. This means our program is working exactly as intended. Congratulations! Step by step, we have built and completed our expense tracker app using the DOM. Of course, this can be improved further. For example, right now, if you submit the form without entering any data, it still accepts it. And if you click delete, the transaction disappears instantly. But the proper way would be to validate the inputs before submission and to ask for confirmation before deleting. Also, if you reload the page, all the transactions are gone. You could enhance this by saving them in local storage so that they remain even after a reload. These are exactly the kinds of tasks you will take on to improve the user experience, and they all fall under basic JavaScript. I hope by now you clearly understand how important the DOM really is. Even for such a small app, you can see how beautifully everything comes together with vanilla JavaScript. And just like this, we can perform all kinds of functional operations using the DOM. By working on this project, you have already seen practical use of many DOM elements. Since I work with the DOM regularly, I was able to pick them up quickly and explain them to you in a simple way. So, if you practice a little, you will also be able to pick these things up very quickly. For example, the prepend method came to my mind while working, so I showed it up here. Then there's the remove function. Since we already have append, it makes sense that remove would exist too. Similarly, there's another function called removeChild, which directly removes an element from the DOM. In this way, we picked up a few new things along the way. Hopefully, by now, your fear of working with the DOM has gone away. I have tried to cover just about everything. At the beginning, I showed you how to select different DOM elements, then how to traverse them, and how to handle parent-child relationships using simple methods. I also showed you how to create new elements, add children, remove them, select elements in different ways, and listen for various DOM events. These are the things we used most often in our daily work. And the best part is, we did all of this with plain vanilla JavaScript without using jQuery or any other library. Although in the past, most people would rely on jQuery for these small tasks. Now you can see how easily it can all be done with JavaScript itself. So that was my complete course on the DOM. I'm wrapping up this video lesson here. At the very beginning, I promised to share some project ideas with you. At the end, after practicing this project, you can try building a few more simple applications like a calculator, a to-do application, a form validator, or even a weather app. Make sure to maintain CRUD functionality so that create, read, update, and delete all work properly in your applications. Also keep your apps responsive so they run smoothly on different web and mobile devices with JavaScript. If you want even more project ideas, you can follow our Logic Based Labs page. We regularly share different cheat sheets, project ideas, and tech-related resources there. And if you get stuck while working on a project, don't hesitate to mention our Logic Based Labs page and post your code along with the problem details. We will do our best to help you out quickly. You will find the link to the page in the video description. Before I end, just one small request. If you found this video series helpful or learned something new, please let me know in the comments. And if you would like me to create more detailed videos like this, suggest some topics and I will try to explain them in the simplest way possible. Finally, if you enjoyed my content, don't forget to subscribe to our Logic Based Labs YouTube channel and follow us in social media. All the links are given in the video description. Thanks for watching this video all the way through. See you again in another one. Signing out.